Okay, so today we're going to very briefly look at speed, distance, time and the relationship between those three variables, okay? Now you might have done this in science and you might have used like a triangle to work out speed or distance or time, okay, which is often really effective. But today we're going to sort of look at a different approach, okay, in terms of scaling our values, right? So let's look at question 1 here. It says a plane travels 150 miles in 20 minutes. Calculate its average speed in miles per hour. Now speed simply is a measure which tells us how far something travels in regard to a certain amount of time. So in this case, we know that it travels 150 miles in 20 minutes. Okay, but I would want to know how far could this plane travel in 1 hour. Okay. And what we can do is look at this sort of pattern here, this relationship, and use it. Okay, we can scale it to see, well, if it carried on flying at that speed, how many miles would it travel? And it's a case of looking at that time, which is 20 minutes, and thinking, okay, what would I need to do to that to change it to an hour? Okay, obviously I need to multiply it, yeah, I need to increase it. And if you think about it, 20 minutes goes into an hour 3 times, so 3 lots of 20 minutes. So that would give me a time of 1 hour if I multiply this by 3. But if I'm multiplying this by 3, I'd have to multiply that distance by 3 as well, yeah, because it'll be going 150 miles every 20 minutes. So that means, times that by 3, I'll get 450 miles in 1 hour. So there we've got the speed, okay, because it's telling us actually the plane will do 450 miles in 1 hour. So what we say then is the speed of the plane is equal to 450 miles per hour. Okay. Let's look at a second example. So cyclist travels 20 miles in 50 minutes. Okay. So question is then, what would the cyclist's average speed be in miles per hour? Now the trouble you've got here this time is we can't so easily sort of change this to an hour, can't we? You know, like before with this one, we just times it by 3 and we got to an hour, but it's difficult to think, what do I times that by to get to an hour? Okay, it's not going to be very nice. But you don't have to do this in one go. What you can do is break it down into different steps. And we can think, well, okay, if it travels 20 miles in 50 minutes, what would it travel in 10 minutes? Okay, let's make it smaller. So think about it, 10 minutes goes into 50 minutes 5 times. So what I'm doing here is I'm making it 5 times smaller. I'm dividing by 5. So I'm making the time 5 times smaller, which means I'd need to make the distance 5 times smaller. So I'd need to divide this by 5. Of course, I'd get 4. So it can do 4 miles in 10 minutes. And if we know then the cyclist can do 4 miles in 10 minutes, actually then I can work out how far the cyclist would go in an hour. Because 10 minutes nicely goes into an hour 6 times. So I just need to scale it, times it by 6. So if we can do 4 miles in 10 minutes, times it by 6, 4 times 6 is 24. So you can do 24 miles in 1 hour. So the speed would be 24 miles, okay, per hour. Okay. Let's look at the a third one. So a meteor travels 7,500 miles in 150 minutes. Calculate its average speed in miles per hour. So 7,500 miles, 150 minutes. Now, that's so far it's gone in actually longer than an hour, yeah? That's actually 2.5 hours. So again, you need to think, how can I scale this to an hour? Well, we can do the same as we did before, okay? I could actually divide this by, say, 10. Divide that by 10, because if you think about it, 150 divided by 10 will be 15. Okay, so if we're dividing the time by 10, we'd have to divide the distance by 10, so that will be 750 miles in 15 minutes. So in 15 minutes it goes 750 miles, what would we need to do then to work out how far it would go in an hour? Well, of course, we know, don't we, if it's 15 minutes to get to an hour, we'd have to scale it up by 4, wouldn't we? Okay, so we times it by 4. 4 quarters of an hour is 1 hour. Okay, so then timesing that by 4, we'd need to times this by 4, and we'd get 3,000 miles in an hour. So in other words, the speed will equal to 3,000 miles per hour. Okay, fantastic. Okay, fourth one. A male sprinter covers 100 meters in 10 seconds. Calculate his average speed in kilometers per hour. Okay, well, if they can do 100 meters in 10 seconds, and they carried on running like that, obviously that would be impossible, but if they did, they could. It's a case of just scaling it up. Well, if they can do 100 meters in 10 seconds, well then, what would they do in 1 minute? All you've got to do is times it by 6, yeah? Because 10 seconds goes into a minute 6 times. So if we do 6 lots of 10 seconds, we get a minute. So that means the sprinter would go 600 meters. You can do 100 meters in 10 seconds. In a minute, you do 600 meters. That's in a minute. Let's keep scaling it. Let's go to 10 minutes. So if I went to 10 minutes, it would have to times the time by 10. So I'd have to times the distance by 10. So that would be 6,000 meters. Okay, in 10 minutes. Times this then by 6, yeah? Because we get that then to an hour. Times this by 6, well, 6,000 times 6 is 36,000. So 36,000 meters in 1 hour. And of course, it's asking for kilometers, so the speed would then be 36 kilometers per hour, since of course the kilometer is 1,000 meters and we've got 36,000 here, so the speed of that sprinter would be 36 kilometers per hour.